Good day everyone. So for today, let's tackle about the acidity and basicity of salt solutions. So first of all, let's begin with what we already know. So we know that acids and bases, when they react, they neutralize each other's effect. They undergo neutralization reaction and the salt and water is formed, right? So in this video, we can determine that salt solutions are not only neutral, they can be also acidic or basic. Salt solutions can be considered as acidic, basic, or neutral depending on the pH, which affects the ions that it interacts with. When dissolved in water, a basic salt yields a solution with pH greater than 7. When dissolved in water, an acidic salts form solutions with pH less than 7. When an acid and a strong base react, the salt that gets formed is neutral. So here's an example. So we can determine that salt solutions can be acidic, basic, and neutral. So these are the salts here. They sodium chloride, the iron chloride, and the potassium fluoride. And I put this HOH here, the hydrogen, the hydroxide, because these ions are present in this aqueous solution, because all of this can form an aqueous solution. That's why I put an AQ here. And for that, if you can still remember with my previous discussion about the neutralization reaction, this is how it will work. So we have here the sodium and the hydroxide comes together, and the chloride and the hydrogen comes together, the iron and the hydroxide, the chloride and the hydrogen, and the potassium and the hydroxide and the fluorine and the hydrogen. So these equations are like double replacement equation. So these salts are formed. The sodium hydroxide plus the hydrogen chloride, and in the second equation is the iron hydroxide and the hydrochloride, and in the third equation is the potassium hydroxide and the hydrogen fluoride. So in the first one, this first equation, in order for us to determine what are the basic, neutral, or acidic salts, let's determine first if these salts are strong acids or bases. So let's start with this equation number 1, and then this is a strong base. Put this strong base, while this one is a strong acid. And the strong base and strong acid comes together, it will form a neutral solution. So we'll put N here. So basically this salt solution is a neutral solution. So in the second equation, we have here a weak base. And this is a strong acid. So when weak base and strong acid comes together, so what will it will form? So basically the strong acid wins. So this solution is a acidic. So in the third equation, we have here a strong base and a weak acid. So when strong base and weak acid comes together, the strong base wins. So this is a basic solution. Have you understand it, guys? So this is the long way in determining what are salt solutions if it is acidic, basic, and neutral. So let's proceed to the next slide. So I'm gonna show you the shortcut method. We have salts here, the one that I used example earlier. So this is how it will work, guys. So let's just use color coding para dali rata maka-identify. So we have here the base, the color black, and the acids are color yellow. This and this. So as with the third one, so the acid, just put it right here to determine the acids and the bases. So here it will go. So our hydrochloride is a strong base. So it's a strong base. We'll put it strong base. And our sodium hydroxide is a strong acid. So this is a neutral solution. While iron hydroxide is a strong acid, and the hydrogen chloride is a weak base. So this is a acidic solution because strong acids and weak bases, strong acids always wins. So in the third one, we have here weak acid, which is the hydrogen fluoride, and a strong base, which is the potassium hydroxide. So it's a basic solution. So it's easy, right? And that's it. And for you to easily identify the strong acids and strong bases, weak acids and weak bases, we'll just figure out what are the weak acids, strong bases, strong acids, and weak acids. For more equations, how to solve the pH of acids and bases, our co-reporter Novame Maglasang has a video of it, and So that's why I didn't include it here in my video. And that's it, guys. Thank you for watching.